Hello, my name is Kim Christensen. I am from FENAGY, and today I want to talk a little bit about supply temperatures from air source CO2 heat pumps. And I have to start with explaining a little bit about two different components inside the heat pump, which is the compressor and the gas cooler. So first, the constraint of the compressor. Normally we are drawing the compressor map inside a diagram like this, where we have suction pressure and temperature on the x-axis, and we have discharge pressure on the y-axis. And the green dotted line is the envelope, and we have some cutouts of the envelope. Down here in the lower right corner we have, it's not relevant for heat pumps, because it's more for refrigeration systems, because heat pumps we always operate at very high discharge pressure. So we up here in the upper part of the diagram, either in the left corner or the right corner. In the left corner it's a winter situation where we have very low suction pressure because we have to take heat out of a very cold air. And in this case we can have very high discharge temperatures because the pressure ratio of the compressor is extremely high. Therefore we can have problem with oil, and eventually we can break down the compressor. So that we have to be careful about. In the upper right corner, it's a summer day, we have high suction pressure, we have high mass flow through the compressor, we have high mechanical stress on the compressor and the valves, we also have high oil carryover. But the problem to supply temperature in this case would be that the discharge temperature of the CO2 gas is very low. So having a very low gas temperature is difficult to create hot water. Now I'm jumping into the gas cooler and start again with the winter situation. Here we have to operate the compressor at a little bit lower pressure, as I explained before, not to have too high discharge temperatures. So it's the purple curve, and of course we can heat water from low temperature 40 degrees up to 70 degrees. But in this case the problem is if we want to heat water even higher, then we start in the heat exchanger. In the gas cooler we have very limited temperature difference, and limited temperature difference means that the heat transfer would be limited. So that is the constraint in winter condition. In summer condition we would have it differently because the discharge temperature is extremely low. Of course we can operate the compressor at a much higher pressure, at 150 bar maybe, but we can heat the water from 40 to 70, but if we want to heat the water from 40 to 80, again we see a limited temperature difference in the middle of the heat exchanger, whereas we are not exchanging any heat from the CO2 side to the water side, and therefore we are not heating the water. So this is a limitation we do see there. As a heat pump manufacturer, we have to make a control system that is protecting the compressor on one hand, but also giving the needed supply temperature as high as possible very often. So what we are doing here is, in our controls at FENAGY, we have implemented in the control system a limitation if the air temperature is too low, below -5, or higher than 15, there's a limitation. We also have a limitation to the return water temperature in this corner. An example is if it's -6 outside, we cannot create the 80 degrees, we are limiting to 78. If the return water temperature is more than 40, we also have a limitation there, and therefore maybe the controller would limit to 75. The same thing would happen if it's a very warm day. We are limiting the supply temperatures to 72, and further limiting if the return is too high. And that's the way we have done it at FENAGY. You're welcome to ask questions to us whenever you need it. Okay, thank you very much. Bye.